Okay, now if you'll notice our directions or our instructions on the left-hand column include not only the overall strategy, grouping, and AC, but we've also got the diamond method. So the first step of the diamond method is to do the AC diamond. So if we have 8x squared minus 6x minus 9, I'm starting exactly like the AC method. 8 times negative 9 is negative 72. B is negative 6. Now I could list all factor pairs of AC. So I'd have 1 times negative 72, negative 1 times positive 72. I'm still looking for a pair that will add to give me B. Now we've done this, so we know that it's going to be 6 and negative 12. So I put 6 and negative 12 on these sides. Now if I were doing the AC method, I would use those numbers to split my middle term. If I'm doing the diamond method, I don't. Let's look over at the steps of the diamond method. It says do the AC diamond. That's what I just did. Now it says write AX over each term in the east and west sections of the diamond. Now A for this problem is 8, so I'm going to put 8x on top of that 6 and 8x on top of that negative 12. I know this looks a little bizarre, but just bear with me. Now, the next step of the diamond method, I wrote AX over each of the terms in the east and west, parts of the diamond. Now I'll simplify those fractions. So we have 8x over 6 is one fraction. Both of those are divisible by 2, so that's 4x over 3. I had 8x divided by negative 12 in the other section. Both of those are divisible by 4, so that simplifies to 2x over negative 3. Now this is the part where I really actually hate the diamond method, but it's just so slick I can't not teach you it. It's really pretty cool. This is a total trick. There is no logical reason, well, there is a logical reason, but it involves a 4-page proof, which I know you don't care about. But 4x plus 3, think of it just as a trick. I'm going to say for no good reason, I'm going to change that into 4x plus 3. 4x over 3 is not the same as 4x plus 3, but we're just going to do that because that's what the trick tells us to do. Similarly, for the 2x over negative 3, we'll change that to 2x minus 3, and that is actually how the polynomial factors. My warning, 4x divided by 3 is not 4x plus 3. I don't want you to get confused there. It's just a complete trick, but the trick works. So let me just give you some pros and some cons. I've still got the problem here to kind of reference. The pro, it's so slick, it's almost magical. Here are the cons, and I think they're significant. Because it's magical, it isn't logical. There is no checking your work along the way. I can show you why this works, but I cannot show you why this works in 5 minutes. It's a pretty involved proof. When I had students first show it to me, I had to go through and prove to myself it really worked before I would agree to teach it. So it's very involved and it's not easy to understand why it works. Another con, if you make a small mistake, you will get a colossally wrong answer. In other methods, if you make a tiny mistake, your answer might be a little bit off. For this, it's all or nothing. It also could lead to a mathematical misunderstanding, like that last step. So don't ever let yourself think that 4x divided by 3 is the same as 4x plus 3, because it's not. It's just simply a trick. So here are the places. This is the giant warning label that comes with the diamond method. If you forget to take out the greatest common factor in the first step, you're toast. If you forget to take out the greatest common factor for any other method, you're going to be a little bit off, but not too much off. You can always fix it later. Here, you cannot fix it later. You've got to remember. If you forget to simplify those fractions, again, you're toast. You're not just a little bit off, you're way off. And if you have non-standard variables, you just have to be careful. Some of our last examples will deal with having non-standard variables, so you'll see how to deal with those. But you've just got to be aware that you're going to have to think a little bit if you just don't have a plain old x squared and a plain old x. Okay, so in the next video, we've got 8 examples of the diamond method. In the next video, we'll do the first 4, and in the last video, we'll do the last 4.